Hey, Eric, welcome, and thanks for joining me today.
Oh, thank you for inviting us.
So I'm with Eric, who is the CTO of Zededa. We're here in an embedded world where, of course, AI is everything, right? Every booth has AI inside of it. Every booth is talking about AI.
Yep.
But the thing I haven't seen when I've talked to customers, I don't know if you have, you tell me, I've asked them, how many of these have you deployed? And I'm expecting answers of, we've got 10,000 units in the field or 1,000, and they go, no, we've got 5 deployed, et cetera. So tell me about what you're hearing from customers, and tell me what you're seeing from your customers about deploying Edge AI.
Yeah, so I think that that's one of the big challenges, right? So people know how to get the stuff, whether it's in the lab or in a limited pilot. They can find a model, they can actually try the stuff out. Yeah. But then when they say we need to deploy this stuff to 50 or 500 sites, okay, how do you actually do that? And there's 2 parts of that. One is making sure that the initial deployment works, and then it's saying, oh, but wait, I want to update this AI model, right?
Right.
So do I need to update the inference runtime? What needs to be updated, right? And then, yeah, you need to worry about other things in the bigger picture, which is, oh, but that's running on some version of Linux, and I need to be able to deliver security patches. And in many of these environments, whether it's embedded, whether it's factories, whether it's remote sites, how do you actually do that securely and at scale is a big challenge.
Yeah. So you mentioned one thing I want to dig a little deeper into, because you're a CTO, so you're brilliant and technical. You mentioned MLOps and how you get models to be done from the cloud. That's not a static environment in areas where you guys play, like industrial. How do you do fine tuning? How do you keep all of your infrastructure updated? Like, how are you guys thinking through that as a data?
Yeah. So one of the things we're looking at, I mean, the day one problem is really figuring out, do I have the right combination of models and hardware, right? Yeah. You can do this stuff. You might need GPUs, you might be able to do it with capable CPUs. It all depends on the problem you're trying to solve, what performance you actually need out of this. Yeah. But then you want to be able to test that stuff. Yeah. So one of the things we're looking at is helping people with the testing things, so they can actually try things across a range of hardware with a range of models. And there's plenty of models available, open source models, etc. So it's not like you have to go through a lot of effort, but you have to make sure you can build a solution that actually works, right? And now you have gotten to step 1. But then observing that, what will that actually look like? Which of the existing cloud tools can you actually use?
Yeah.
There's still something that we're learning together with our customers what makes sense, right?
Yeah.
And then, how do they go and drive the updates across that system?
Yeah, and to your point, one of the things we're seeing in terms of friction is, it's very easy if you have a standalone AI deployment. Yeah. Standalone AI deployments don't exist at the edge, right? Like, that's not something that we see in meaningful volume. And so, what we're hearing from customers is, hey, I need all of your products to all have the ability to have AI inside of them, right? I need integrated acceleration, whether it be on your, smallest box that, maybe a 6-watt or a 10-watt CPU, or all the way up to your 65-watt bigger CPU. Can you talk about the heterogeneity of hardware at the edge and how you deal with it as a software leader?
Yeah, no, I think that, what we actually set out to do from day one is making sure that orchestration actually works, so that people can take the same journey that people have been on in the data center and cloud over the last couple of decades, right? Yeah. And sort of like, people started with virtualization, moved to containers, to Kubernetes. It's the same type of journey that we're seeing at the edge.
Yeah.
And enabling that so that people can do this in their on their at their own pace, right? With their own applications, with partner applications. And a key thing there is, particularly at the edge, you're going to end up with more hardware heterogeneity, because many of these deployment projects, the hardware replacement cycle out in a factory, out on a truck, right, out in a retail location, is not 3 years, it's more like 7 years.
Right.
So it means that even if you think you start with something that homogeneous, well, the devices you're going to buy 3 years from now, they're not going to be the same hardware. You're going to get better things for better price, right?
Right.
And so naturally you get heterogeneity there at the hardware level. But then being able to have sufficient technology underneath so you can actually get the behaviors you want, whether that's combinations of old virtual machines running Windows, because that might be your bread and butter application, and you're transitioning and you're adding more stuff with container, right?
Right.
It might be other combinations where people say, hey, I'm in a factory automation environment, I need some real-time support out of this. And you need to be able to bring that in as well. And then choose, am I building this stuff for sort of a rack somewhere in the back, whether it's in the store, whether it's in a factory, Am I building this stuff to go on the factory floor or, under the counter at, coffee shop, right?
The dirty
What-
edge, as we sometimes
Yeah.
call it. Yeah.
What form factor do you need, right? And it could be different. It could be the same applications, but in different environments, you might want to say, well, we need more capacity. You're going to have a small rack in the back.
Yeah.
So the software, this is all open source, right? What's running at the edge is open source. The challenge is actually putting together the system so it gets the right properties. Anybody could say, oh yeah, I'll just take Linux and I'll take some, I don't know, container runtime and okay, but who is actually responsible for patching that thing, and how do you make sure that the system actually works across the board?
Yeah, but let me dive into that because I think you mentioned something, but I think it's a little nuanced. Of in traditional compute deployments, you run one operating system, and you upgrade to the latest operating system. Where we play and where you play, and we partner together often in manufacturing environments, for example. Can you talk about these heterogeneous OS deployments and kind of how that actually plays into what Zededa is doing with EVOS?
Oh yeah, no, I mean, I think that many cases people have some legacy, right? Or they have something that they want to transition at their own pace. So they might have various flavors of Linux-based solutions. They might have various flavors of Windows, right, that they're running there. I mean, if you walk around here at Embedded World, I ask people, these HMI systems with screens, right, that sit in a plant, well, they're typically running Windows, right? That seems to be quite common even today. But then what do you actually need in addition? And what do you actually want to put in the same server out at the edge, right?
Yeah.
It could vary depending upon the solution, but we're seeing things where people might run various Linux distros, right? You might want to just run pure container workloads, Kubernetes, etc.
Yeah.
And there might be things coming down the road as well with Wasm, right? Sort of like things that can have a larger span in terms of what type of hardware it can run on, where you can even think about bringing that stuff into the microcontrollers if you want. So you can have a common sort of architecture and a common way of orchestrating this stuff.
Yeah.
But so it is a very broad sort of range of hardware. The good thing is that Linux and that open source ecosystem in theory works, right?
Yeah.
In practice, you have to figure out things with device drivers and firmware.
Yes.
You all know this stuff,
Compatibility, right? Different versions,
et cetera.
Yeah, of course. So as you think about, and as I think about the idea just of simply, hey, I have a Windows application running in my factory that I've been running since 2001, and hey, I don't want to change it, right? This is tried and true. And so, as you think about these container based operating systems like EVOS and like others with Linux, it's, hey, you can actually run that Windows application here. And oh, by the way, you can have a more secure virtualized PLC over here. You can have your, potentially robotic arm over here, et cetera. It's the amount of mix and match of that is really hard. So can you talk about how do you think about that orchestration problem?
Well, I mean, at some level, we've done this orchestration in the data center. In some times in the past, we've referred to what Zededa does as sort of VMware for that, right? I mean, the sort of like hypervisor background that you can take anything and you can run it in a virtual machine.
Yeah.
Might not be the most efficient, but it's at least a way of getting that level of compatibility.
Yeah.
And then you bringing in these other things is, you just need to make sure that you have the hardware, the device drivers, et cetera. You have the right level of abstraction. Yeah. So a lot of this is being able to provide a level of abstraction where the applications, they don't care whether they're running on a low Atom-based thing or some really souped up thing with 3 GPUs. Maybe some applications need those GPUs, right?
Of course, yeah.
But other applications shouldn't actually care, right?
Yeah.
So a lot of that is those abstractions that we've had with virtual machines, with containers, et cetera.
Yeah, and we're trying to make that simpler in a lot of ways. And it's a hard problem to your point of, we have our entry and our Atom products today. We have our Core Ultra, we have our Intel Core, we have our Intel Xeon, et cetera. And so, as we've been thinking about it, we try to break it down simply and just say every level of that hardware heterogeneity is going to need integrated AI one way or another.
Yep.
So can you talk about how do you run AI models like VLMs and VLA models alongside more of those legacy VM style containers that you might have inside of EVOS? How do you guys think about running those models?
I think that you sort of had to carve up enough resources for the separate pieces. And if they're virtual machines, it's actually relatively straightforward at the sort of higher level abstraction, right? You say this thing gets this many CPU cores, it gets this much memory, et cetera, right? But then when you get into more sort of performance critical pieces, well, now you might need better hardware isolation support.
Yeah.
And even if it's not actually, sort of a class of real-time control loops, but even in other cases, you want to make sure that, okay, these applications don't actually interfere with each other in some destructive ways. So some of the work we've been doing together with Intel is leveraging the Intel CMT technology for being able to do isolation at the level of caches in the memory cell system.
Yeah.
And now you can say, okay, these real-time apps, now I can actually make sure that even if this other application, this other VM, this other container is suddenly getting a lot of work, it's not going to slow down this other piece.
Yeah, prioritize the one that I need for real-time, nanosecond, millisecond latency.
Yeah, and doing that through the hardware, right? Through the software stack, but also through the hardware. So, yeah. We know how this stuff behaves. And then figure out, what is the actual I/O architecture? Do you care about the network performance as well? Do you need to have specific technologies there around guaranteeing network bandwidth and latency as well? So it depends on the actual use case, how much of this stuff you need, but I think it's critical to have the capability. So you have the flexibility to say, here's my set of workloads I want to deploy today, but tomorrow I might want to have a different mix in terms of the type of applications. People might initially not think about, PLCs that are very time critical. Right. They might start with, 100 millisecond cycle time, 500 millisecond cycle time, but they want to see the capability of being able to do this stuff with the other use cases in that domain, right? Yeah. So see, okay, does this architecturally and working with these partners, these providers, does that mean that we can get down to 10 milliseconds to 1 millisecond, right? Because now they have the flexibility of innovating purely in software, right?
Yeah. I'm curious about your opinion on this, because we've got opinions from customers, and it's obviously aligned to where our vision is. But one of the things that we've heard is having a shared and common hardware with integrated acceleration, along with the CPU, the NPU, the GPU, etc., somewhat makes that orchestration problem simpler than having to orchestrate that across multiple accelerator cards. Can you speak to how you think about the differences of how you orchestrate within a single homogeneous system as opposed to multiple accelerators along with a CPU to be able to do both real-time as well as AI workloads?
I mean, I think fundamentally it gives you the flexibility. The user gets the flexibility of how they want to combine things, right? You could start today and say, I'm going to have 3 separate computers sitting out there running 3 separate workloads. Okay, that might be a good way to get started, but then you see, okay, now I need to worry about, space, right?
Yeah.
Is this actually space efficient? Where is it sitting? Where is it located? Is it in a rack, in a cabinet? But then you also don't have necessarily the flexibility to say, but I want to deploy a 4th application. Well, where do I have room for that one? Well, nowhere. So if I can actually have a bigger box, I can now actually have that flexibility, that headroom to have a slightly more hardware capacity for new applications.
Yeah, and I think that's part of what we're seeing also is that customers are saying to themselves, okay, today I might need just this, but I know that in the near future, I'm going to need some more. And, oh, by the way, to your point, that workload consolidation story, it's becoming so obvious from a TCO and from a space standpoint, especially to your point at the far edge, right?
Yeah.
You described the rack in a nearby data center, maybe not as big of constraints on power and space, but some of the form factors customers are asking us to go into in manufacturing and industrial environments, like you mentioned, of doing a virtual PLC deployment. These spaces are not going to get bigger, so you can put in, to your point, 3 different systems or, a big system with 3 GPUs. It's like, no, it's got its space and it's defined, and everything else is not going to change in order to fit the compute in the environment.
Yeah, that they have to put it somewhere else, right? Because, many of these sort of cabinets that are sitting on a manufacturing floor, they're fixed size, right? Bringing in another cabinet, that's complex, right? So you want to move your stuff to being about the software, right?
Yeah.
And then having the hardware that could support the software evolution. So, and that level of flexibility, I think, is actually key. And as well as being able to say, okay, what's the next generation of hardware? Is it simple to come in there and replace it with something that fits in the same space, right?
Yeah.
But it's actually something that has more capacity. Right?
Yeah, and that's how we're viewing it. For example, marketing plug here. Our Core Ultra Series 3, we put that on 18A, which is the leading node, which has power efficiency. And you go, well, hey, power matters. Yeah, certainly power matters a lot. But when we looked at it, we said, actually, we can stay inside of the same power envelope generation on generation. And instead of having, say, a decent number of AI processing, say 9 or 10 tops, we got up to 180 tops, but in the same TDP envelope, in the same power envelope. So effectively, you can have the same size box, the same size systems. It's just, you can effectively replace accelerators generation on generation. And so to your point, we're looking at it like, if we can deliver to people more computing, more AI processing, integrated in the same TDP envelope, it just reduces friction in all of these fixed environments. Because the heterogeneity also of the types of factory deployments, there is no one-size-fits-all way to deploy hardware architecture and hardware inside of industrial environments.
So are there particular applications that you see people, AI applications that you see people deploying in these environments?
Yeah, and so some of the things we've looked at is, for example, in things like the industrial PC, they're starting to talk about almost Copilot style, I don't mean Microsoft Copilot, but Copilot style implementations where the operator can actually speak to the machine in a natural language processing way of, hey, tell me how the diagnostics are working on this. And so instead of them having to take their eyes off of the production line, effectively they can be actually being talked to about how things are going with the precision, the yield, the timing, etc. The other one obviously is robotics, right? Everybody is talking about it. You know, and I know both we and Zededa are involved in robotics. It's been on factory floors for the last 5 to 10 years. Obviously, humanoids have become very much the story of today, and they could be a really exciting future. But people are starting to look at new and emerging VLAs, so vision language action models for robotics, moving away from more traditional computer vision and taking advantage of generative AI. So as we think about our hardware, that's kind of our North Star of how are we making our architecture of hardware scalable for these vision language models and vision language action models. And industrial robotics is absolutely one of those key use cases for us.
Yeah, no, I mean,
what are you seeing?
So I mean, what we see today, where people are actually deploying in production, yeah, that's a bit more, sort of regular vision applications, right? But sort of models for doing this, and sort of like, very useful things in terms of paying the bills, in terms of reducing costs, in terms of, doing predictive maintenance, etc.
Yeah, defect detection. Yeah.
But I think the thing you mentioned with the VLA thing is, yeah, that's fascinating, because today, if you look at the vision applications, models, right, that's something that someone took and trained somewhere, right? And then you say, well, it's not good enough, so now we need to retrain it. Well, yeah, but the capability of the vision and models combined with the LLMs means that, no, you can do what you're saying. The operator over there can say, but wait, I'm seeing these defects that you didn't catch, right?
Right.
And could you please go look for this as well, right? And the model is general enough, the vision model, that it can actually go figure that stuff out. So now you're not programming anymore, right? You don't need a data scientist to do this stuff. It's actually the operator, if it's sitting on site, sitting remotely, whatever.
Right, because they can bring their expertise too, right? Like that's how you train a model and how you make sure it's not, to your point, it's not a research assistant doing a giant frontier LLM model. It's the machine operator who may have been in that factory for 25 years and understands and knows things and can actually teach the VLM and the VLA model, hey, you were wrong about this. So for the future, please update this. And then, the cycle starts, right? Where it gets retrained and RAG happens and fine tuning happens and the cycle could repeat.
Yeah, no, it's sort of like the sharing. Yeah. It's not like what people think about today with LLMs is that, hey, I'm talking to this very smart AI, right? And it's sort of like, that's where the intelligence is. No, here it's really sharing, right? The actual operator is sharing, getting stuff back. And you can use this stuff to train the next generation operators as well, which I think is actually key.
Yeah, and to me, that's the key where we get so excited about technology like yours. Of if you can solve that MLOps problem of, hey, the operator is effectively training the VLM or the VLA on the job, and then you can actually deploy that to the rest of your factories and learn from your whole workforce. Yeah. We can unlock some pretty insane stuff.
And at the same time, paying attention, it needs to be secure. You don't want to spread sort of bad stuff, right? Whether it's training data or something else, right? Yeah. You need to be concerned about privacy. Is this particular factory owner okay with sharing their learnings, of course, through their machine builder, et cetera, right? So there's plenty of sort of interesting academic problems here, but it's clear that the need is actually there, right? And people actually go figure this stuff out as we go forward. But yeah, security, privacy is going to be there as well. So.
And that, to me, that's one of the foundational tailwinds of on-premise AI. Like, I just don't see a cloud model in the example that we gave before, where, to your point, there's proprietary data and information that's being exchanged between the operator and, that's individualized to that factory operation. And so if I'm one of those providers, I don't necessarily want that going back to the cloud, even if it's feasible, which normally it's not in terms of the volume and magnitude of data to be able to process everything in the cloud. To me, local AI is necessary for that security, privacy, as well as just practical matters of latency and
Hey, you definitely want to do the inferencing, but even as you do retraining, right? There are these various approaches that people have done with federated learning and hierarchical things, teacher-student type setup, where you don't have to tell them everything, right? You don't have to give other people your raw data, but you can actually share some of your learnings if you want to, right?
Yeah, like MOE models, and tuning those for industrial manufacturing as an example, segments for the edge is going to be fascinating to me, because when it's an MOE model for, I would call more of it a human interaction, let's call it, a chat bot or something like that. It could look at the internet, scrape the data and sort of learn, but learning the industrial manufacturing or many edge industries like medical and healthcare, et cetera, that knowledge is not on websites, right? It's in the heads of the experts, and it's like, how do you extract that in a way, to your point, that is MLOps friendly?
Yeah,
it's
I know, and I mean, we see this stuff. We have use cases in oil and gas where the sort of drill master at the oil field, right? And those people are retiring, right? They have 40 years of experience doing this job, right? So how do you train the next generation, right? It's not only about training AI; it's using AI as a tool for actually sharing this stuff with the next set of people.
So I'm looking forward to where we're driving at the edge. I think overall, the excitement to me that you all are bringing to the edge with really cloud native principles, but in on-prem and local locations, combined with our bringing more AI acceleration to the edge to allow those things to happen. It's like our use cases are going to drive the more complexity in orchestration, right? Because there's going to be more devices that are going to be smarter and have AI integrated, and to your point, we know how to do this, right? It's Kubernetes and it's cloud native.
But you need
the OS that can be safety critical in everything that you're delivering.
And you need to be able to optimize that stuff, so you know that, okay, on this particular GPU, this particular accelerator, we're getting the best possible performance, because you don't want to deploy the new one and then run it the same way, the new generation of hardware, and it runs the same way as it did on the old one. You're not taking advantage of the new ones. You need to, at some level, retarget things to the new hardware that gets deployed, right? And that's all about orchestrating the stuff and operating it.
All right. I'm thoroughly excited.
Right.
I'm hoping that next year at Embedded World, we'll get to talk, and there'll be lots of AI that's come out of pilots and into production. And hopefully we've helped with our integrated AI acceleration. You've helped with great orchestration and your EVOS. And so thanks for joining me today.
Yep. Thank you.